This is Unit 2, Number, Algebra and Geometry, a non-calculated paper, and it's the 2012 paper. Question 1. Richard's car uses 1 litre of petrol every 8 miles. Petrol costs £1.30 per litre. Richard drives 240 miles. Work out the total cost of petrol the car uses. So we know for every 8 miles, it's a cost of £1.30. And Richard drives 240 miles. And we want to know what that cost is. So first thing to do, 240 divided by 8 gives me 30. Now the reason that we've done this, we have 30 lots of 8 miles in 240, which means we must also have 30 lots of £1.30 to pay. So we can then do 30 times £1.30, and that will give us the cost for 240 miles. So we've realised that he's travelled 240 miles, and to do that you divide by 30 and you get your 8 miles, and we know 8 miles is a cost of £1.30. So we can times £1.30 by 30. Now the way I would do that is break it up. 30 times the £1, which will just give me 30, and then 30 times the 30p, or 0.3. So the way we can break that down again, to get rid of this decimal, I times it by 10. So 30 times by 3 would give you 90. Now because we times it by 10 up here, we need to remember to divide our answer back by 10, which will give you 9, because we're actually doing 30 times 0.3. So we need to remember that it's 9, not 90. We just did that to get rid of the decimal. So then if we wanted to add up our total cost, we've got 30, add 9, which gives us 39. Now it's in pounds because it's his cost for petrol, so that would be £39. So question 1, the mark scheme. The mark scheme states that if they can see 240 divided by 8 or 30 is seen, you get 1 method mark for realising how many 8s go into 240 and then using that. The second mark is for using your answer to that. So even if you didn't get 30, if you got a different answer here, you could still gain a mark for using your answer and timesing it by the cost per litre. That is my second method mark. So my first one was for working out 240 divided by 8. My second method mark was 30 times 1.3. That needed to be seen. And the last mark is an accuracy mark or answer mark for timesing 30 by £1.30 correctly and getting 39 or 39.00. So an accuracy mark for stating what your answer was. Question 2. Here is a list of ingredients for making apple crumble for 2 people. There's a list of ingredients. Down here a conversion chart. 1 ounce, 28 grams. We've got 1 tablespoon, 15 millilitres, 1 teaspoon, 5 millilitres. Anne is going to make apple crumble for 5 people. Work out how much flour she needs. And it clearly states, give your answer in grams. So we're looking for answer in grams, flour, 5 people. If we go up here, we know that for 2 people, you need 4 ounces of flour. So 4 ounces of flour is enough for 2 people. So if we scale this down, for 1 person, we must only need 2 ounces of flour, divided both by 2. Now the question states Anne's cooking for 5 people. So if we've got 1 person needs 2 ounces, that must mean that for 5 people, we're going to need 10 ounces of flour. All we've done there, 1 person to 5 people times by 5, 2 ounces of flour to 10 ounces of flour times by 5. Now, last point says, give your answer in grams. So 1 ounce is equal to 28 grams. We've got 10 ounces. So 1 ounce to 10 ounce, we've times by 10, which must mean we need to do 28 times by 10. 28 times by 10 gives you 280 grams. That will be enough flour for 5 people, and it's in grams like the question has stated. Put that in my answer box. Question 2. A, where do we get the marks? So, we get our 2 method marks here and an accuracy mark because it's out of 3 marks overall. The first method mark is for scaling down to find out what one person is and then timesing back up to 5 people, as that's what the question is asking for. That's your first method mark, those 2 steps. So scaling it down to 1 person and finding 5 people. If you've used an alternative method to find out how many ounces of flour for 5 people, that will also get you that first method mark. Second method mark is for converting it to grams, so when we had to times by 10. That is your second method mark for realising that you need to go from ounces to grams. And the final mark is an accuracy mark or answer mark for getting 280 grams correct. Part B. David is making an apple crumble. He uses 140 grams of butter. Work out how many people he is making apple crumble for. So we've got 140 grams of butter. Now if we look back over to our conversion sheet, we know that 28 grams is 1 ounce. So we know that 28 grams gives us 1 ounce. And we also know 1 ounce of butter can make crumble for 2 people. So that 1 ounce of butter could also make crumble for 2 people. Now we've got 140 grams. So we need to work out how many ounces that is. In order to do that, 140 divided by 28, and then that will give us how many ounces. So 140 divided by 28. Well, we know that 28 times 10 equals 280, and we know that 140 is half of that. So 28 times 5 must equal 140. So 148 divided by 20 gives us 5. So we know that he's used 5 ounces or 140 grams of butter. So he's used 5 ounces of butter. How we know that? We knew that 28 grams was 1 ounce, and 28 times 5 equals 140, so we have to times the 1 ounce by 5, so it's 5 ounces. Now, we also knew, back from our conversion sheet, we said 1 ounce was for 2 people. We've got 5 ounces, so if 1 ounce equals 2 people, 5 ounces, well, we've multiplied by 5 here, so we'll do the same to our number of people. So David must be cooking for 10 people. So my answer over here, 10 people. And that's worth 2 marks. So, mark scheme for part B. You get 2 marks for this question. The first mark is a method mark, and that is for realising that 140 grams of butter is the same as 5 ounces. And then you get an accuracy mark or an answer mark for realising that 5 ounces is enough butter for 10 people. So, by you working out 140 divided by 28, and then converting that for your ounces is one method mark, and then for realising that it's 10 people, gives you that second mark. Question 3. Here is a right angled triangle. So we've got length of 15, 9 and 12 centimetres. The shape below is made up of 4 of these triangles. Work out the perimeter of the shape. So straight away I can see that if this length is 15 centimetres, that must mean we've got 15 centimetres here, 15 centimetres here, 15 centimetres and 15 centimetres. My next step would be, if I look at this 12 centimetres here, that would give me the full length 12 centimetres there. Now if I look, the 9 centimetres at the bottom here gives me 9 centimetres there. So I've got 12 as my full length, and I've got 9 taking up that bit there. So in order to get this bit, I must have to do 12 take away 9, which gives me 3 centimetres. Now, that gives me this part there, 3 centimetres. So the full length was 12. I took away the 9, as I knew that was the length of the bottom of the triangle. it's given me 3 centimetres, which means I must have 3 centimetres on that part, 3 centimetres there, and 3 centimetres there. So to work out my perimeter, I have 15 times by 4, which gives me 60 centimetres, and I have 3 times by 4, which gives me 12 centimetres. When added together, 60 add 12 gives me a total perimeter of 72 centimetres. Question 3. The mark scheme for this one, so this is a total of 3 marks we're looking at. 2 method marks, 1 accuracy mark. The first method mark is for realising to work out this bit here, you have to do 12 minus 9 equals 3. And the second method mark is for realising 15 times 4 and 3 times 4. So realising that you had to time both by 4. That was your second method mark. And then an accuracy mark for correctly identifying 60 add 12 is 72. That is your 3 marks. 2 method, 1 accuracy. Question 4a. Express 54 as a product of its prime factors. So we know prime numbers are numbers with only 2 factors. So if we draw a factor tree for this one, start at 54. So we could break that down into 2, which is a prime number, and 27. 27 we could break down, so we could have 9 and we times that by 3. Circle 3 is that as a prime number, so then you've got 2 factors. Then carry this one on, so we've got 3 times by 3, which is a further 2 prime numbers. So that means our final answer will be 2 times 3 times 3 times 3, or if you prefer to write it, 2 times 3 cubed. Question 4b. Find the lowest common multiple of 45 and 54. So they're looking for the lowest multiple of both these numbers that they have in common. So it's only 2 marks, and it's also part B to what we've just been doing on part A. So if we wanted to start this, I would draw a factor tree for 45 so that we can get the product of its prime factors and compare that against 54. So 2 numbers that times together, 5, which is a prime factor, and 9. Split 9 down into 3 and 3. So that means that 45 as a product of its prime factors would be 5 times by 3 times by 3, and we already know that 54 would be 2 times by 3 times by 3 times by 3. So from this we can use a Venn diagram to find the lowest common multiple of these 2 numbers. So 45 and 54. Now remember, any pairs of numbers that appear in both we put in this middle overlap section. So for example, they both have a 3 here, so we can place that in the middle, and they both have another 3 as a factor, place that in the middle. If we were working out the highest common factor, that would be that middle section. The question is asked for the lowest common multiple. So with our remaining numbers, we need to put them into our Venn diagram. So for 45, they've got 5 left over, and for 54, we've got the factors of 2 and 3. So to find the lowest common multiple, we would look at all the numbers we can see in the Venn diagram and multiply them together. So 5 times by 3 times by 3 times by 2 and times by that last 3. And if we work that out, 5 times 3 is 15, times by 3 again is 45, times by 2 gives me 90, and if I times 90 by 3, I get 270. So my lowest common multiple is 270. If you're unsure on this method, you could always list the multiples of 45 and list the multiples of 54 until you get the lowest common multiple. Mark scheme for 4a. So express 54 as a product of its prime factors. You get 1 method mark for an attempt at prime factorisation. So an attempt might only mean you've managed to do 2 correct divisions, but perhaps not a complete factor tree. You'd still get the method mark for attempting. The second mark is an accuracy mark for clearly labelling 2 times 3 times 3 times 3 as your answer, or 2 times 3 cubed. So method mark for attempting to find it, and then your accuracy mark for the actual answer. Part B is only worth 2 marks. So you get a method mark for correctly identifying 45 as a product of its prime factors, and then an answer mark for finding 270 as your lowest common multiple. So that's a method mark for correctly identifying the prime factors of 45, and an accuracy mark for correctly identifying 270. If you listed the multiples of 45 and 54, you could get a method mark for at least 3 multiples listed of both. This can include 45 and 54, and then again you get the accuracy mark if you got it correct. So if you had 270 clearly labelled as your answer. Question 5. You can use the graph opposite to find out how much Lethna has to pay for the units of electricity she has used. Lethna pays at one rate for the first 100 units of electricity she uses. She pays a different rate for all other units of electricity she uses. Lethna uses a total of 900 units of electricity. Work out how much she must pay. So if we take a look at the graph, like the question has suggested, we've got the cost of her units of electricity, and the scale is going up in tens. And then she's got the number of units used, which is going up in 100. So the question says she pays one rate for the first 100 units. So one rate for the first 100 units, and then a different rate for all other units used. So our first point would be to find out for her first 100 units how much it's going to cost her. So first 100 units. To do that, we're going to flip back over to our graph. So number of units, 100. If we read up the graph and we cut across, we can see it's halfway between 20 and 30, which means she must pay £25 for that first 100 units. So first 100 units, by looking at the graph, we can see she pays £25. Now, we've done our first 100 units, and it says she does a total of 900 units. So we've got a total of 900, and we've already worked out our first 100 units, so we've got 800 units left to look at, and this will be at the second rate of the cost of her electricity. So I would be tempted to find out what 100 units is worth at this second rate, and then to times that by 8. So for the second rate, we're going to look at what 100 units is equal to. So cost-wise, at her second rate, so we're going from after the first 100 units. So the cost for 100 units at that second rate, we go from 100 to 200 and read up. So we can see for 100 units at the second rate, it costs from £25 to £35, which means it must cost £10. So, second rate of 100 units is £10. Now I've already said that we've still got 800 units left. So we need to times 10 by 8. We've got 100 units is £10 and we need 800 units. So for 800 units at the second rate, we're going to do £10, because that was 100 units, times by 8, which gives me £80. Now, I'm not finished there. I need to add them up together. So we've got first 100 units was £25, and the second 800 units was £80. So that gives me a total of £105. So down here, Lethna has paid £105 exactly for her 900 units of electricity. Question 5, mark scheme. So this is a total of 3 marks overall. You get 1 method mark for correctly identifying, or a correct method for the first 100 units, or if £25 is seen, so if that's on the graph or for your workings. You get the second mark, or the second method mark, for identifying the second rate. So whether that's £10 that's seen, or a correct method to find £10. So a mark for each rate of the electricity. And then your final one is an accuracy mark for correctly identifying £25, add the 80, 105, 105 is your accuracy mark. So that's a method mark for each rates that you found correctly, and then an accuracy mark for identifying 105. Question 6. The diagram shows a wall in Neil's house. So we can see that the total area of the wall, 3 metres by 2.4 metres, and it's got a door in it, 2 metres by 0.9 metres. Neil is going to cover the wall completely with tiles. Each tile has a width of 30 centimetres and a height of 40 centimetres. Now straight away I can see that the wall and the door are measured in metres and my tiles in centimetres. So I'm going to just quickly convert these to metres to save me forgetting later. The tiles are sold in packs. There are 6 tiles in each pack and each pack costs £15. Work out the least amount of money Neil needs to pay for the tiles. You must show all your working. So if the question says show your working, that's exactly what I'm going to do. First thing I'm going to look at is the area of this wall without the door, as Neil is not going to be decorating the door, just the area of the wall. So in order to do that, we're going to find the area of the wall, including the door, and we're going to minus the area of the door. So area of wall, 3 times 2.4, minus area of door, 0.9 times 2. Now, if you're unsure with decimals, 3 times 2.4, if we times that 2.4 by 10, we would have 3 times 24, which will give you 72. Now, I've times my 2.4 by 10 to get to 24, so I must make sure that I scale my answer back down by dividing by 10. So 3 times 2.4 is actually going to be 7.2. Same over here. Instead of 0.9 times 2, I could say that 9 times 2 equals 18, so times my 0.9 by 10. So I must need to make sure that I divide my answer back to 1.8, because I'm timesing by 0.9, not 9. So in which case, my area of wall, I've got 7.2, and I'm taking away 1.8. So we've got 7.2 minus 1.8. 12 minus 8 is 4. 6 minus 1 is 5. So the total area that we're going to be covering is 5 metres squared. So we've got the area of our wall that we're going to be decorating. Up above here it says that we're decorating it with tiles width 30 centimetres or 0.3 metres, height 0.4 metres. So the area that one tile would cover will be 0.3 times 0.4, which would be 0.12. So they also say that they come in packs of 6, which we will deal with in 2 seconds. So if we look at 5.4 metres squared for the area that we're decorating, we want to know how many tiles that will be. We'll be doing 5.4 divided by 0.12. So again, decimals, if you're unsure about that, you could times them both up by 100. So we could have 540 divided by 12. You could then use your bust up method. 12s into 5 don't go. 12s into 54. 12, 24, 36, 48 is 4. Remainder 6. And 12s into 60 are 5 times. Now we don't need to scale this back down because we times both of these by 100. Whereas up here, we only times one of them by 10, so we had to make sure we divide our answer by 10. Down here, the 5.4 has been times by 100 and 0.12. So our answer, we would need 45 tiles to decorate our area of 5.4 metres squared. Now the last point we need to remember, 45 tiles is what's needed, but in the question, tiles come up in packs of 6. So we need to find out how many packs we need to buy. In order to do that, 45 divided by 6. So again, use your bust up if you need to. 6's into 4 don't go. 6's into 45, 7, and we've got a remainder of 3. 6's into 30, 5. Now remember it's 45.0 at the bottom here, so we must make sure we've got the decimal on top here. So 45 divided by 6 gives me 7.5 packs. Now the question says, what's the least amount of money Neil needs to pay? Now we can't buy 0.5 or half of a pack. So if we round 7.5 up, that must mean that the least amount he will buy is 8 packs, and he'll have a spare half pack or 3 tiles left over. If we look at the cost of this, as it wants his least amount of cost, so 1 pack is £15, we've got 8 packs. So 8 times by 15 which gives us £120. So my final answer, £120, is what it will cost for Neil to decorate his wall. Question 6, mark scheme. So, 4 possible marks, 3 method marks and an accuracy mark. Your first method mark is for correctly identifying that he's not going to decorate the whole square. It's going to be the area of the whole wall minus the area of the door. So 5.4 is seen with the method, that's one method mark. The next method mark is for doing the area of the wall divided by the area of the tiles. Now it clearly states with the correct converted units. So knowing that it's 0.12, because it's 0.3 times 0.4, not using the centimetres. So that second method mark is for correctly identifying 5.4 divided by 0.12, giving you how many tiles? 45 tiles. The last method mark is for identifying how many packs of tiles, so for correctly dividing by 6. So that was 7.5, and if you rounded it to 8 packs, that was your third method marks. So again, that's 45 divided by 6, which gave you 7.5. And if you correctly identify that as 8 packs, that is your third method mark. And then an accuracy mark for seeing that 8 packs times the £15 will give you £120. Question 7. Using the information that 170.2 divided by 4.6 equals 37, write down the value of 1702 divided by 4.6. And that is for 1 mark. So as we can see, 170.2 has got 10 times bigger and gone to 1702. So that must mean our answer has to get 10 times bigger too. So instead of 37, our answer will be 370, because the number that we're going to divide has got 10 times bigger. Part B, 170.2 divided by 460. So if we look back at the original question, it was divided by 4.6, and it's now divided by 460. So that there, the number that we're dividing by, has actually got 100 times bigger. This will make our answer 100 times smaller, because if you're timesing by a much bigger number, your answer is going to be much smaller. So instead of 37, we're going to have 0.37 as our answer. Again, just 1 mark, 0.37. Part C, 3.7 times 4.6. So we had 170.2 divided by 4.6 equals 37. So we were going to rearrange that. Our original question would look like this. Now the one in front of us, or for part C, they've told us 3.7 times 4.6, and they want to know what the answer is. So we can see that 37 has got 10 times smaller. It's gone from 37 to 3.7. So instead of 170.2, it must have to get 10 times smaller. So instead of that, it's going to be 17.02. Our 37 has gone to 3.7, so therefore our answer must also get 10 times smaller. Question 7, mark schemes. So these 3 are all 1 markers. So you get a working mark for seeing 370. The examiner gives you a mark for seeing 0.37, so another working mark. And for 17.02 for the last one. 3 marks in total for question 7. Question 8. Here are the first 5 terms of an arithmetic sequence. 4, 11, 18, 25, 32. Write down, in terms of n, an expression for the nth term of this sequence. So the first thing we're going to look at is the difference between each of these numbers. So I can clearly see here from 4 to 11, we've added 7. 11 to 18, added 7. So we know it's a linear sequence rather than a quadratic one. It's only 2 marks. So if the difference is 7, we know the first part of our nth term is going to be 7n. Remember, n is the position in the sequence. If we were just going to write 7n, we know that that equals 7, 14, 21, 28, and so on, 7 times table. Now the sequence we've got is 4, 11, 18, 25. So what we've actually got is this. So we must have to look at, from 7 to 4 we've taken away 3, from 14 to 11 we take away 3, 21 to 18 we've minus 3, so our nth term must be 7n, take away 3. So my answer there, 7n take away 3. We've looked for the difference, which has given us 7n. That gives you your 7 times table, because of course n is the position in the sequence. 7 times 1 is 7, 7 times 2 is 14, and so on. 7n minus 3 gives us our actual sequence. Part B. An expression for the nth term of another sequence is 3n squared minus 1. Find the fourth term for this sequence. So they want the fourth term, or the fourth number in that sequence. So we're looking over here, 3n squared minus 1. Now we know n stands for the position of each number in the sequence. So we want the fourth number, that's going to be in position 4. So we can replace that, n with 4, so it'd be 3 times 4 squared minus 1. So we're thinking of BIDMAS. 4 squared is 16, so we've got 3 times 16 minus 1. 3 times 16 gives me 48, and we still need to minus that 1, which will then give me 47. So the fourth number in this sequence, or the fourth term, is 47. Question 8, mark scheme is a total of 2 marks. So you get one method mark, or one working mark, sorry, for 7n, and one working mark for minus 3. So for example, if you could only spot that the difference was 7, so you knew it was 7n, you could still get half the marks for that. And then if you could only see the minus 3, perhaps you got the 7n wrong, then you could get 1 mark for that. So each bit, the 7n and the minus 3, is worth a mark. 8, part B, is a method mark and an accuracy mark. So you get a method mark for correctly identifying that if it's the fourth term, you will substitute 4 instead of n. So for correctly substituting 4 in and getting 3 times 16 minus 1. That'll be for your first method mark. And the next mark is an accuracy mark for correctly identifying that is 47. Method mark, fourth term, substitute 4 in. Accuracy mark for correctly identifying 47. Question 9. A, B, C, D, E, F, G, H is a regular octagon. It's 8 sides. PAE is a straight line. PAE is a straight line. Angle PAB equals y. Work out the value of y. Now my first step would be to work out the exterior angle here. And I know exterior angles in polygons equal 360 divided by number of sides. And as this is an octagon, 360 divided by 8. If you need to use bus stop for that, you can. If not, you'll be able to see 45 degrees. So my green angle, my exterior angle there, is 45 degrees. I can also see that this round here is a straight line, so going across. So that must be 180 degrees. So if I was continuing that round, it would be 180 degrees, add on the 45 that I've just worked out. So we had our angles in a straight line, which is 180 degrees, add on the 45 degrees, which we just worked out, is 225. So this is angles from straight line equal 180 degrees. So if this whole bit here is 225 degrees, we can see that y is exactly half of that. Y is round to there, and if we were to add round here, that would be 2y. So we've got y is exactly half of what we've just worked out. So it's half of the 180 and the 45. So we did 225 divided by 2, which gives me 112.5 degrees. So my answer down the bottom, 112.5 degrees. Worked out the total angle and divided by 2. Question 9, mark scheme. So this is a total of 4 marks for this one. So 3 method marks and 1 accuracy mark. The first method mark is for correctly identifying exterior angles in polygons is 360 divided by 8. So if that is seen, if 360 divided by 8 is seen, or 45 is seen, that is your first method mark. So perhaps you wouldn't be able to necessarily work that out, you'd still get the mark for it. If you've got 45, that means you can carry on with the question. Second method mark is for correctly identifying that we had angles in a straight line, 180 plus the 45. So the second method mark is for realising that they total to 225. And the final method mark is for realising that y is half of that. So for realising you need to divide 225 by 2. And then your final mark is your accuracy mark answer of 112.5 or 112.5. So if for some reason if you couldn't divide that by 2, you could get 3 out of the 4 marks. And your last mark is for correctly dividing that by 2. 4 marks in total. Question 10a. Write 125,000 in standard form. So we need a decimal between 1 and 10. So where would I put my decimal point that would make that number between 1 and 10? Well, it's going to be 1.25. If it went here, 12.5 would not be between 1 and 10. Standard form, we know we need it 10 to the power something. So what do I times 1.25 by to get to 125,000? Well, I times it by 100,000. So I need to convert that to 10 to the power 5. That's 1 mark, 1.25 times 10 to the power 5. Part B, 8 times 10 to the minus 4 this time, as an ordinary number. Now, for example, if it said 8 times 10 to the minus 1, that's the same as saying 8 times 0.1, which would be 0.8. We've got 8 times 10 to the minus 4. So that's a 10,000th. 8 times a 10,000th, which would give me 8 10,000ths. 1 mark for each of those. Question 10, mark scheme. So 1 mark for each of these. So you get a working mark if 1.25 times 10 to the 5 is seen. So both parts of that have to be correct, the 1.25 and times 10 to the 5. The next mark, another working mark, 0.0008 must be clearly stated. That is also 1 working mark. So in total for question 10, 2 possible marks. Question 11. The diagram shows a solid triangular prism. All the measurements are in centimetres. The volume of the prism is V centimetres cubed. Find a formula for V in terms of X and give it in your simplest form. So the question again, the diagram shows a solid triangular prism. All the measurements are in centimetres. The volume of the prism is V centimetres cubed. And they'd like you to find a formula for V in terms of X. Give your answer in simplified form. Well, first of all, the volume of this triangular prism is going to be the area of this triangle. So that's going to be half the base times the height. And then we're going to need to times it by the length to give us the full volume. So the volume of this is going to be area of triangle multiplied by the length. So this would give us a half times base times height times the length. So we can now start to look at these numbers. So my base is 2x, so down here a half times 2x. My height is x, and my length, which is going along here, x at 10, which we're going to put in brackets, as that's the length. So now we can start trying to simplify this. Well, the first thing we can spot, if I was doing a half times 2, gives me 1. So that already can cancel down to x times x times x at 10. So I've gotten rid of my half times a 2, which is just 1, which we know we don't have to write in front. If I was simplifying further, x times x gives me x squared, and then I've still got the bit in brackets here. And now I can multiply out the brackets. X squared times x gives me x cubed. X squared times 10 plus 10x squared. So then on my answer box, to clearly state what I've done, v, because I need to write it as a formula, equals x cubed at 10x squared. If we check the question, find the volume formula for v in terms of x, give your answer in its simplest form. We've worked out our simplest form, we've given it as a formula. So question 11, total of 3 marks awarded for this question. So the first one is a method mark for correctly identifying that the volume is a half base times height times length and substituting those values in. So a method mark, if you correctly substitute the values in to a half times base times height times length. The next one is an answer mark. So if you correctly simplified that down to x cubed add 10x squared, that would be an accuracy mark for your answer, sorry. So the final mark is a working mark. Now in the mark scheme it states that you must have v equals a cubic expression in x. So by this they mean this isn't your final answer, you need to clearly state it as a formula like the question asks, which means v equals a cubic expression in x, or we've got a cubic expression in terms of x. So that'll be your third mark there. So realising that this wasn't the end product, you had to have v equals x cubed at 10x squared. Question 12. The diagram shows a cuboid drawn on a 3D grid. 3 of the vertices, so the corners or the points, are P as 320, Q 300, R 304. Label the vertex Q with a cross. Now this is only one mark. So looking at these, most of us are probably used to the 2D coordinates looking like this. So we've got your x value and your y. All we've got here, we've still got x and the y, but we've also got a z, and that's what makes it 3D. So if we were focusing in on Q with these coordinates, tells us that for x is 3, y 0 and z 0. So if we were starting our origin or our O here, Q has gone along 3 in the positive direction, so it's gone along 3, and then it has not moved up or down because y is 0, and there is also 0 for z. So Q must be at that point there. And the question says to clearly state with a cross. Part B, the vertex S is shown on the diagram. So that is up here. Write down the coordinates for the vertex S. So if we, up here, we're looking for the coordinates of this point here. So we start again at our origin. We can see that for the x value, it has gone along 3 because it's not in line with this origin. So it's gone along 3 for the x. Now it's also moved in terms of y as it has gone up, and it has moved in terms of z as it's gone along here. So if we were looking at these values, we can see that for all of them, x is 3, so q has gone along 3, so that must mean that s is also 3 for the x value. We were looking for p here, saying it's gone up 2. The highest that this one's gone up is also 2. And again for s, if we look, we said that it has moved for the z-axis. So if we were looking on the z-axis on these ones, we can see r went along by 4. So this one, if it's another point on our cuboid, must also have gone along 4. So that again, we've used these coordinates to see how far along we either go on the x, the y and the z, and we see if our position S has moved along any of those axes. And in this case, it's moved along 3, up 2, and then it's come out 4. And the reason we know those numbers is from using these coordinates here. Question 12. So 1 mark for part A, 1 mark for part B. Part A asks you to label the vertex Q with a cross. So if it's correctly labelled with a cross, that is 1 mark. The second mark, write down the coordinates of the vertex S. So you needed 3, 2 and 4 to be correct for that mark. So there's no marks if either one of them is wrong. So taking time to ensure 3, 2 and 4 are all correct gives you that second mark. Question 13, part I. Write down the value of 4 to the power minus 2. So we know that the negative indice makes this a fraction, so we've got 1 over, and then underneath we'll be placing the 4 squared. We still need our to the power 2, but we no longer have the negative, and we converted this into a fraction. So then we can work out 1 over 4 squared, which is 4 times 4, which is 16. So my answer on the line, 1/16. Part II, 64 to the power a third. Now we know that to the power a third means that they want the cube root, same as if we had 16 to the power of a half, they'd want the square root of 16, which would be 4. And they've asked for 64 to the power of a third. So they want the cube root of 64. So you are trying to work out something times itself 3 times equals 64. We know the answer to that is 4. 4 times 4 is 16, times 4 again will give me 64. So the cube root of 64 is 4. Question 13i for the mark scheme. This was one possible mark, and that is for correctly identifying that 4 to the minus 2 is the same as 1 over 16. So we get 1 mark for that part. 14ii, 64 to the power of a third, for correctly identifying that that is the cube root of 64 that they are after. So you get a mark for stating 4. Question 14a, factorise x squared add 5x add 4. Now we know that factorise is the opposite of expanding, so we want to put this into double brackets. Now in order to do that, we know that the numbers in the brackets, I've got a sum to give 5, and when multiplied together, they must equal 4. So when multiplied together, they must equal 4. So the way I would do this, think of our factors of 4, bearing in mind that they're going to have to sum to give 5. So for example, 2 times 2 is 4, but they did not sum to give me 5. Or 4 times 1 gives me 4, and they do sum to give me 5. So if I was looking to put into my double brackets, I've just realised that the numbers 4 and 1 will fit in these brackets as they times to give 4 and sum to give 5. Now in order for me to get my x squared, I know that I must have an x here and an x there. So if I'm looking for my signs inside my brackets, everything here is positive. So x add 1, x add 4. If we wanted to check this, we could multiply it out, and that would give us x squared add 5x add 4. So 14a, mark scheme. Part A was worth 2 marks in total. You get a mark for each bracket that is correctly identified. So for x add 1, 1 marking mark. For x add 4, 1 marking mark. So for example, if you had x add 1, x add 3 here, you'd still get the 1 mark for this bracket, but you wouldn't get the mark there. Same as if you had this one correct, but not this one, you could still gain 1 working mark for that. So both brackets correct will give you the 2 working marks. 14b, expand and simplify. Expand means we need to get rid of the brackets, and simplify. So we want everything in this first bracket to multiply everything else in this second bracket. So we've got 3x minus 1, 2x, add 5. There are a number of ways that you might expand these double brackets. For example, we might focus on the 3x and say that that needs to multiply by both numbers in here, and the minus 1 does as well. So we need to do the 3x times by 2x and 3x times 5. So we need the 3x times 2x, which will give me 6x squared, and the 3x times 5, which will give me 15x. So this number has multiplied everything in this bracket. We now need to focus on the minus 1. So minus 1 times the 2x and minus 1 times the 5. So minus 1 times 2x will give me minus 2x. Minus times a positive gives me a minus. Minus 1 times by 5 will give me minus 5. So that's not finished. We need to simplify. So at the moment, I have 6x squared plus the 15x minus the 2x and minus the 5. So I can see here 15x minus 2x can be simplified. So if I've got 6x squared, 15x minus 2x will leave me with 13x, and I've still got that minus 5 on the end. Question 14c. Write as a single fraction 1 over 2x add 1 over 5x minus 1 over 3x. Now when we want to write this as a single fraction, we'll be looking for a common denominator. So if we focus in on these numbers, 2x, 5x and 3x, a common denominator for all three of these would be, well, we know we've got x's in all of them, so it'd be something x, and we need to think of a number that is in the 2, 5 and 3 times table. So our smallest common denominator there would be 30. If in doubt, write out your times table until you find a number that appears in all of them. So we then need to convert all of these to have this common denominator. 1 over 2x. Well, if we look there, we have times across here by 15. So whatever we do to the bottom, we do to the top. So that first one will be 15 over 30x. And then we've got 1 over 5x. And we need to ask ourselves, what have we multiplied here to get from 5x to 30x? Well, we've times by 6. Whatever we do to the bottom, we do to the top. So we've got 6 over 30x. And our last one, 1 over 3x. What have we done to get to 30x as our common denominator? We have times by 10. So on the top, we must also times by 10. Now, if we were pulling all of this together, we'll have 15 over 30x. So 15 over 30x. Then we look at the question. We need to add our converted 1 over 5x. So add our converted 1 over 5x, which is 6 over 30x. Then minus 1 over 3x, which we have converted to 10 over 30x because we need our common denominator. So we need to remember to minus, very important to focus on these signs, minus 10 over 30x. And then we can work it out. 15 add 6 gives me 21, minus 10 gives me 11, and then our common denominator of 30x. I'll pop that on my answer box to make it clear. 2 marks that question was worth. 14b, the mark scheme. So this was possible of 2 marks. You get the full 2 marks if you correctly identified 6x squared at 13x minus 5. So it does say that if you made a mistake somewhere, so for example, if you only got 3 out of these 4 terms correct, you could still get 1 of the working marks. And it also states if you got all 4 terms, but with the wrong sign, so the wrong signs in front of them, you would get 1 of the marks. So 2 marks if it's completely correct with the correct signs. 1 possible mark if perhaps you got some of the signs slightly muddled up. 14c was out of 2 marks. So first mark is for correctly identifying the common denominator, whichever method you may have used for that, which was 30x. And an answer mark or accuracy mark for your answer, correctly showing 11 over 30x. So a method mark for spotting that you needed to find a common denominator, or attempting to find a common denominator, and an answer mark for 11 divided by 30x. So you need to have at least 2 of these fractions correctly made into equivalent ones with your common denominator. So we've managed to convert these successfully into 30x on the bottom. You need to have at least 2 of them correct to get that method mark. And then your accuracy mark, 11 over 30x. Question 15. M and N are 2 points on the circumference of a circle, centre 0. So M and N on the circumference, centre 0. The straight line AMB is the tangent to the circle at M. Angle MON equals Y. Prove that angle BMN equals a half Y. So first things, let's look at what we know. Line OM is a radius, because it's gone from the centre to the circumference, as is ON. So OM equals a radius, ON equals a radius, therefore OM must equal ON. So on that, they are equal lengths. That means that this triangle is therefore an isosceles triangle. So we've got an isosceles triangle. We know that isosceles triangles have 2 equal sides. They also have 2 equal angles, here and here. So isosceles triangles have 2 equal sides, which we've marked on. They also have 2 equal angles. So, if we wanted to find one of those angles, we know that the angles in a triangle add up to 180. And if we took away y, it would leave us with what these 2 angles are. And as we know they're exactly the same, we would divide by 2 to get one for each of those. So we know that angles in a triangle are 180. If we take away y, that leaves us with what these 2 angles would be. We know they're exactly the same, so we can divide that by 2, and that will give us those 2 angles. Another way to write this, a half times 180 minus y. So instead of dividing by 2, we've times by a half. So far we have worked out what that angle is, but the question is asking for this angle here, BMN. Now, we know that AMB is a tangent to the line MO. That means this whole angle must be 90 degrees. And we know that that blue angle is a half 180 minus y. So in order to work out this orange one, we would say the angle BMO, so that whole angle BMO, the orange and the blue part, equals 90 degrees, as the angle between the radius and tangent will always equal 90 degrees. And we just want the orange part, so if the blue part is a half 180 minus y, the orange must be 90, the full angle, minus. So that again, we know that this entire angle is 90, because the tangent to the radius gives us an angle of 90 degrees. We know the blue part is this, so we've taken that away. Now, if we were to multiply out the brackets, half times 180 is 90. A half, or minus a half, times minus a y is going to give us a half y. So we've got 90 minus 90, which cancels it out, which leaves us with the angle that they're asking for, BMN, so angle BMN, the orange bit, not the blue, it's going to be equal to a half y. And that's my answer. So, question 15, mark scheme. Now, this has a total of 5 marks to be gained here. The first mark is for correctly identifying that OM and ON are equal, they're both radii, which creates an isosceles triangle. So, you get a working mark for clearly showing that it's an isosceles triangle, and you've realised OM and ON are the same. Second working mark is for realising that if these are the same in an isosceles, you'll have 2 equal angles that are the same. So that's OMN and ONM, the 2 blue marked angles. So that's your second mark for correctly identifying that they're the same, and therefore using the formula to correctly work out what these are. So that's using what we knew about isosceles triangles and formulating a half 180 minus y if we were to try and work out those angles. The third mark is for realising that the angle with the orange and the blue, so the angle between the tangent and the radius, would be 90 minus what we have just worked out. So that's for realising that we have just worked out the blue, and for realising that to work out this whole angle here, it would be 90 minus the blue, and that will give you the orange angle. Last 2 marks are communication marks. So you get a communication mark for stating that you knew it was 90 degrees as the angle between the radius and the tangent is equal to 90. So you needed to clearly state that as part of your proof. And the last mark for a correct conclusion and clearly stated that the angle BMN is a half y. So you need the final conclusion with it clearly stated. Question 16. In the diagram, A is the point -2, 0, B is the point 0, 4, and C is the point 5, -1. Find an equation of the line that passes through C and is perpendicular to AB. So first things first, we're going to be looking at equations of lines. Remind ourselves C is the intercept, or the y-intercept, and M is our gradient. So let's first look at the line AB. We want to find the gradient. So at the moment we've just got y equals mx plus c. To work out the gradient of the line AB, we know that's change in y over change in x values. So we can do that. So the change in y is 4 and the change in x is 2. So 4 over 2, so the gradient is 2. So far for our line AB, we have y equals 2x at c. Now we don't want the equation of this line, so we can stay at this and use what we've learned, our gradient, to try and find a line that passes through C that's perpendicular to AB. Now, perpendicular lines have a gradient that is a negative reciprocal of the line that's perpendicular to them. So if the gradient of this one is 2, the line that we're working out that's going to be perpendicular must have a negative reciprocal gradient. So negative reciprocal of 2 would be minus a half. The reciprocal is a half and the negative reciprocal is minus a half. So if we continue working over here, for our line that passes through C, we know y equals minus a half x at C. Now they want the full equation, so we need to work out the y-intercept. To do that, we can find values of x and y, substitute them in and work out C. So to find values of x and y, there needs to be a point that's on the line, and we know that the line we're working out passes through C, where the x value is 5 and the y value is minus 1. So y value is minus 1 and the x value is 5. So minus a half times 5, minus 1, minus a half times 5 would be minus 2.5 plus C. So in order to work out C, we can add 2.5 to each side. Which will give me 1.5 is equal to C. So my y-intercept of the line that passes through C is going to be 1.5. And I said before, the gradient was minus a half. So the equation for the full line, y equals minus a half x plus 1.5. That in total was 4 marks. Question 16, the mark scheme. So a total of 4 marks can be awarded for this one. Your first mark is a method mark for attempting to find the gradient of the line AB. So method mark for attempting to find the gradient of the line AB. Your second method mark, which is obviously dependent on your first, is an attempt to find the perpendicular gradient of the line that passes through C. So that will be your second method mark, which is you realising that the negative reciprocal of 2 was minus a half. Your third method mark, which again is dependent on your second, is for realising that we can substitute in the values of minus 1 for y and of 5 for x to our new y equals mx plus c for the line that passes through the point C. So that is your third method mark for correctly substituting in those values to create the y-intercept. And your last one is an accuracy mark, y equals minus a half x at 1.5 or 3 over 2. So 4 marks, attempting the gradient, gradient for a perpendicular, substituting in the values, and then accuracy mark for clearly stating y equals minus a half x at 1.5. Question 17. Rationalise the denominator of 6 minus root 5, 6 add root 5 all over root 31. Give your answer in its simplest form. So first things we're going to do is deal with the top up here. So we need to multiply out these brackets. So we've got 6 minus root 5 multiplied by 6 add root 5. So we've done this before in this test. So we're going to do 6 times 6, 6 times root 5. So we get 6 times 6 gives us 36. 6 times root 5, or 6 lots of root 5, will just be 6 root 5. So that 6 has multiplied everything in the bracket. We now need to do root 5 times everything in the bracket. So root 5 is going to times minus root 5 is going to times 6, and minus root 5 is going to times plus root 5. So minus root 5 multiplied by 6 is 6 lots of minus root 5. So we put the minus out here, and it's 6 lots of minus root 5. Then minus root 5 times plus root 5. Minus root 5 times root 5. Now, one of our laws with surds, if we imagine root 25 times root 25, well, root 25 is 5, and times it by root 25 again is 5, gives me 25. So if we were doing root 25 times root 25, it just equals 25. So if we look down here, minus root 5 times 5 Well, from what we've just demonstrated, root 5 times root 5 will just be 5, so minus root 5 times root 5 will just be minus 5. Now, we haven't finished there, we need to simplify this. So we've got our 4 parts there, or 4 terms. We've got 36 plus 6 root 5 minus 6 root 5 minus 5. So I can see that in the middle, if I've got add 6 root 5 minus 6 root 5, they're just going to cancel each other out. So I'm left with 36, take away 5, which is 31. That's my numerator, that's what's on top. We go back to the question. We've just simplified this to 31. So we are left with 31 over root 31, because we've got root 31 on the bottom. Now, another law when it comes to surds, we want to rationalise the denominator. We are going to times both the top and the bottom by that denominator. So if we times across, 31 times root 31 will just be 31 lots of root 31. And like we demonstrated before, root 31 times root 31 is just going to leave us with 31. Because remember, when we did root 25 times root 25, it ended up just being 5. So we can simplify that even further. If we see we've got 31, root 31, divided by 31. So if we cancel out like this, we are just left with root 31. So our final answer, fully simplified, root 31. So question 17, last question, and it's a possible 3 marks to be gained for this one. The first one is a method mark for correctly multiplying out or expanding these brackets. So that is 1 method mark for correctly expanding out these brackets. Now they do say that if you have for some reason got your incorrect signs, but all 4 terms are correct, that can be ignored and you could still get the method mark. So for example, you had a plus here instead of a minus, but all 4 terms were correct apart from that, you could still get the method mark. Second method mark is for correctly identifying that we must times both the numerator and the denominator by root 31. So that's for realising to rationalise the denominator, we need to times the top and the bottom by root 31. And that final mark is an accuracy mark for correctly putting root 31 as your answer. So for fully simplifying, 31 over root 31 divided by 31. So that's your final mark, an accuracy mark. Total marks of this paper is 60 marks.